Hello everyone, my name is George and I'm a senior software engineer at Collabora. In this presentation I'm going to talk about the audio experience on the desktop with PipeWire. Let's first start by looking at what is PipeWire. So PipeWire is a system daemon whose main goal is to provide a means for applications to share audio and video between each other. And not only that, but also between applications and devices, allowing devices to be presented to applications in a unified way. So all kinds of media devices like cameras, sound cards, Bluetooth headsets, and so on. These are all devices that can be accessed through PipeWire in a unified way. Another goal of PipeWire is also to unify the use cases around multimedia applications, having a single API and a single means of them presenting themselves to the user. So in the past we had, for example, PulseAudio that was meant to drive the audio for the desktop use case and to some extent also the embedded use case. But then we had also JACK, which provides the audio server for professional audio. And these are two very different kind of use cases where you want to use audio and audio devices on your system. And PipeWire is trying to bridge those two and more. And another goal of PipeWire is to address security concerns, especially when it comes to running applications within containers. Nowadays we have Flatpak that packs applications into containers that have limited permissions, and PipeWire plays an important role to ensuring that these applications only get access to the media that they need. So if they need access to the microphone, it's just going to be the microphone, not anything else, for example. So let's look at the current state of PipeWire on the desktop. Right now it provides a well-working PulseAudio replacement, which I use daily on my desktop. And it has also a JACK replacement, so JACK applications can run on top of PipeWire without any issues. It also has a screen capture and camera capture functionality. Screen capture is implemented by the compositor of your desktop on Wayland, which basically grabs frames from the screen and shares them to other applications through PipeWire, while camera capture is also available through Video for Linux, although I don't think any application is using that yet. It's not totally integrated with Flatpak, as at least for the audio part. For the screen capture part it is integrated, for the audio part it's not integrated. So what I said about only sharing the microphone, for example, that is not applicable at the moment. And we also have two implementations of a session manager. PipeWire itself doesn't do any management of the nodes that it has in its graph. So there is a separate application called the Session Manager, which is responsible for orchestrating the graph. When an application connects, it basically finds where's the right place to link it and what kind of media access to give it and things like that. And right now we have PipeWire Media Session, which is the default session manager if you install PipeWire, and has the most functionality for the desktop right now. And we also have Wire Plumber, which myself and my team have developed, that was initially targeted for embedded use cases, but it's catching up also on the desktop side. So let's look at how things look right now if you are trying to replace PulseAudio with PipeWire. So PipeWire ships a set of replacement libraries which implement the PulseAudio API. And if you have them installed, you will see something like that on your terminal. As you can see here, PulseAudio is not running, PipeWire is running, and if you run PulseAudio control, which is a native PulseAudio utility, it shows you that it's connected to some PulseAudio server that is called PipeWire. Same with other applications, of course, like Pavu Control, which is the volume control app of PulseAudio. As you can see here, it has it lists my output devices properly. My input device is here. As you can see, we also have device monitors, just like in PulseAudio. There's no difference. And the devices have profiles that you can configure, so it allows selecting all the profiles that are available in PulseAudio. And you can also see here in the screenshot that I have a Bluetooth headset connected. That's the silver medal device. Bluetooth headsets are also working very well at the moment. And and in this example I also have Firefox connected, playing some music from YouTube. And as you can see, everything works here. The audio level bar works at the bottom, and also there is a selection of the device available. So if I try to select another device there, it will move the stream from Firefox to that other device properly. And something extra that is not exactly visible here, but it's in the background, that this Firefox instance that you see here connected is actually connected, is actually Firefox running in Flatpak. And to enable that, actually there is, apart from the replacement library that I talked about, there is also right now a replacement PulseAudio socket. So a native PulseAudio socket is presented to Firefox, and it connects as if it was connecting to PulseAudio, sending PulseAudio commands, and then these commands are being translated to the PipeWire equivalents. Now let's see how it looks like if you try to replace Jack. Running some native tools like Kiagiadakis control that show the graph of Jack. If you have worked with Jack before, this should be a familiar picture. It shows basically all the devices that are available and all the ports that they have available. And there is also my Firefox instance running over there, and that is connected to this HDA Intel device. That's exactly the same setup as the setup that I was showing in the previous screenshots. And then if you try to run some native Jack application, it works. So here, for example, I have the Calf Studio gear running with one filter configured. Calf is basically an application that allows you to load a couple of audio filters and link them in any way that you like. And here I have a compressor filter, and since I started it, I disconnected Firefox from the HDA Intel device by using the Kiagiadakis control graph, and then I linked it to Calf, and then linked Calf to HDA Intel. And in this scenario, it basically plays audio from YouTube to the device, but first going through the filter from Calf. So audio from Firefox goes to Calf directly, and from Calf it goes to the device. Now, this is all very nice. It was a nightmare to get this with the real Jack before. If you have ever used Jack and tried to use PulseAudio applications together with Jack, you know that it's not very straightforward, because you need to run a PulseAudio server that handles the PulseAudio applications and then route the audio from PulseAudio to Jack. And it's not very flexible. They don't have many outputs from PulseAudio. But in here we have all the flexibility that we want, because everything is native. However, there are a couple of issues in combining PulseAudio and Jack in the same running them as running applications from PulseAudio and JACK together. And in the above example where I linked Firefox to Calf, for example, we can see that there is an immediate usability issue in the volume control application, where in the upper screenshot I'm showing what happens if Firefox is routed to Calf, and in the lower screenshot what happens when Firefox is routed to the device directly. So when it's routed to Calf, PulseAudio applications like Pavu Control here don't understand where this is linked to. They can see that it is there and it's linked to something, but it's not clear where it's linked. There is nothing that represents this Calf node on the PulseAudio side. And of course it's also not able to show the volume meter that is showing on the bottom, because it doesn't know where to catch this audio from. There is a hack to fix that. So what you can do if you want to fix that, sort of, is to run in this case Calf with an additional environment variable that sets this media class property to audio sync, and that basically adds a property to the node object that lets the PulseAudio replacement library understand that this is a device. So the PulseAudio side now thinks that Calf is an output device, and it's going to show it properly in Pavu Control. As you can see, it shows as a separate device. You can even select it as a default device and have applications being routed there automatically. And Firefox is also now also showing properly that it's linked to Calf. But of course there is no volume control on Calf because it's not a real device. It doesn't have the volume properties that other devices have. Now this works sort of. It's not very nice to set it up, and there are also some issues, like what happens if you have more filters enabled in Calf. They will all show up as ports on the same node, and what the PulseAudio side will understand, for example, if you have two stereo filters that have 2 and 2 ports each, that means it will see 4 input ports and 4 output ports, and will think that you have a 4-channel device, not 2 different filters. So it's not exactly something that works so well. And we also see another detail here that okay, when we set Calf as the default device and we start Firefox, Firefox is getting linked to Calf properly. That is done by the PipeWire session manager, which recognizes that node and creates the link. However, on the other side, where Calf is connected to the device, this is a link that has to be done through the JACK session manager, because but the PipeWire session manager doesn't have this functionality, at least yet. It's possible, of course, to implement it. It's nothing that is not. It's all possible. What I'm saying. But right now it doesn't work. So you have to run 2 different session managers, and you have to try and present things in a way that PulseAudio will understand and JACK will understand. So how can we bridge those 2 functionalities? How can we make something that actually works for both use cases nicely? This is an open question. I have some ideas about getting a few things working more nicely. So in the case of Calf, for example, I have some ideas that will help making this better. But there are much more complex JACK setups than running a simple filter. You could have Ardour running, for example, that is a full professional audio workstation with lots of controls and filters around, and it could be hard to get it right. So yeah, it needs some thinking. And of course, I'm currently talking about combining PulseAudio and JACK, which is basically the desktop and pro audio use case. What about other kinds of use cases? What is missing from that? The desktop is pretty simple because we have single CPU and a single sound card, or multiple sound cards, but it doesn't matter. You have multiple microphones, multiple speakers going to one CPU. There are cases that I have worked on in the past. So Wire Plumber, for example, we started the Wire Plumber for automotive grade Linux, which is a distribution base for automotive manufacturers to use in cars. And things in a car look very different. They look like this. So you have multiple CPUs, multiple computers around the car, and each of them does something different, and they all have needs to access speakers or microphones. They may have to share those. They may need to cooperate in some way. There are also special devices like special microphones, for example, that do voice recognition, that have their own processor in them and do some pre-processing of the audio. So there is quite some complexity there, and the main thing that is the thing that is important when you write applications for such a system is for the application to declare its intent when it connects. Because, for example, one important thing to consider is what happens when you have, for example, an application playing music and an application trying to give you instructions on the road to navigate you. These two need to access the speakers simultaneously, but the navigation application has more importance. You need to hear that message and not the music. So there are systems where basically when the application tries to output navigation audio, they basically raise the volume of that stream and they lower the music so that you get a proper sound output. It's similar with little notifications that you may have in your car, like the blinkers, the alarm light sound, for example. When it's on, you need to be able to hear that, and usually it's coming from the speakers in modern cars, and it has priority, so it needs to be heard more than anything else. And in Wire Plumber, we designed basically something that makes that work on top of PipeWire. So applications in AGL, they can declare their intent, their role, and they can connect to PipeWire, and they will say, I'm a music app or I'm a navigation app, and they will get proper routing to the sound output with a certain policy applied, of course. Now, why this is relevant for the desktop? Because it shows us that the use case of the application matters, and these use cases also apply on the desktop. So we have also on the desktop, we have applications playing music, maybe applications doing calls, we have desktop notifications, we may have a screen reader, for example. These are very, very different use cases, and in some circumstances they need to be treated differently, and they could be treated differently, which is actually not a very new idea. It has been there for at least a decade. For example, if you are familiar with KDE, you must remember this phonon preferences dialog. Has been there for a decade or so. And basically, this brings this idea to the desktop. It allows you to configure a different device per use case. Unfortunately, this implementation in KDE didn't go further, so it only allowed you to specify a device, and it was also limited to applications using Phonon and not anything else. And this idea actually comes from the mobile world, where Android, for example, it has this notion of a use case. So your music app goes to the media channel, and your phone call goes to the call channel, and your ringtone goes to the ringtone channel. And they all have different volumes, which is something that KDE didn't have. KDE only allows you to select a device. Android allows you to select volume per use case. And what if we could do both? Actually, we could select both a device, a setup, a session with filters and everything in the Pro Audio case, and also to have different volume per use case. I would love personally to have my music, for example, playing out in the room speakers, while when I want to jump in a call, I want to just open my Bluetooth headset, put it on, and I want the system to automatically understand that the music needs to stop and I'm going into a call, and so the audio needs to be routed to the headset. This is something that I would really love to have also on the desktop. So how do we do that? In WirePlumber, we have introduced two kinds of new objects in PipeWire called endpoints and endpoint streams, where the endpoints basically are something like the nodes that we have in PipeWire. They're just a more abstract term, and the streams are paths associated with a use case. So you would have a music stream, a notification stream, a call stream, etc. And there is a graph that looks similar to the graph of nodes that we saw earlier in QJAK control, but in this case it has, instead of ports, instead of showing the channels, it shows the use cases. So the media player connects to the multimedia use case, the voice agent, the voice assistant connects to the voice assistant use case, and so on. And then the endpoint object has some internal mechanisms going through the policy control to figure out what to do with these streams based on the use case that they have been opened with. So these endpoints, they are not fully adopted in PipeWire. They are not a final design. We may have to change things in the future. It's something that we used in WirePlumber to implement the streams, to implement this functionality in automotive grade Linux. Of course, there is an extension available in PipeWire, and it's actually enabled by default. It's there, but it's not used in the default desktop setup. This is what I mean. Now, before we go ahead and enable that in the desktop, it needs some thinking. How can we bridge those use cases to work together smoothly? This is an open question. I don't have all the answers, but what I know, and the reason that I'm here today giving this talk, is because I believe that it needs cooperation between application developers, desktop developers, and PipeWire developers. So we all need to work together and come up with ideas and see what our vision is for the future, to bridge all those functionalities together and to have something that is revolutionary, that goes beyond what we already know in the Linux desktop and in other desktops as well. So if you have ideas, they are all welcome. We are hanging out on IRC on #PipeWire. And the source code is available on gitlab4desktop.org. There is both PipeWire and WirePlumber. They live in there. If you want to, let's say, to dump your ideas in a ticket, maybe open a ticket against WirePlumber, and we can take it from there. Thank you very much for attending, and I hope to talk to you soon.